let's discuss the negation of universal statements. In this theorem 3.2.1, we are told that negation of a universal statement is actually going to be an existential statement. So in other terms, the universal turns into an existential and the predicate itself gets negated. In symbols, the negation of the universal is an existential statement with the predicate being negated. Let's practice by rewriting the negation of for all prime p, comma, p is odd. This is an example of a universal statement. So again, we need to first start by recalling that the negation of for all is going to be an existential. And also we need to make sure that we negate the predicate. So in other terms, the negation of the statement in question is going to be there exists a prime p such that p is even. Remember, this is a symbol for such that, which sometimes could be written as st, or sometimes it could be replaced with a comma, depending on the context. In other terms, the negation of for every prime p is odd is that there is a prime that is even. And by the way, in this particular case, the original statement is actually false. Not every prime is odd. However, the negation is going to be true. There is a prime that is even, that prime is the number 2. Now, the negation of an existential statement is going to be a universal statement, just like before. We are going to negate the symbol that exists, and it will become for all. And again, we negate the predicate to get the solution. So in symbols, negating an existential statement is equivalent to having a universal statement with the negative predicate. Let's take a look at an example. Write the formal negation for the following. There exists a triangle T such that the sum of the angles of T is 200 degrees. This is an example of an existential, so when I negate it, I'm going to end up with a universal. Next, I need to negate the predicate. So the solution might look something like this. I want the negation of there exists a triangle T such that the sum of the angles in T is 200 degrees. First of all, I'm going to begin by negating the predicate. There exists becomes for all. The domain does not change. Next, I need to negate the predicate. The sum of the angles in T is 200 degrees. That's the same as saying the sum is not 200 degrees, which can be simplified even more by using the function notation as angle sum of T is not 200 degrees. In words, the last two theorems are basically telling me that the negation of a universal is logically equivalent to an existential, and the negation of an existential is logically equivalent to universal. But why? Well, if you think about it, the universal statement is basically saying that the predicate is true for the first x, and the second x, and the third x, and so on and so forth, and this could be infinite. And remember, when I negate the statement with an and, I'm going to end up with a statement that has an or. This is because of De Morgan's law. So the negation of the for all statement is going to become there exists. And vice versa. There exists x in D such that p of x means that the predicate is true for either the first x or the second x or so on and so forth. Which means if I negate that sentence, I'm going to end up with all these symbols flipped around and turned into and symbols. And I'm going to end up with a conjunction, which is in turn going to give me a universal statement.